I think next I want to welcome to the stage Azzam. Azzam, are you here? There he is. Like this. Picking up how we go. Yeah, thanks. Okay. Hi, everybody. My name's Azzam. I'm on product and engineering at a company called Prefect. And I'm going to talk a lot about today about how we use ClickHouse to enable real-time event-driven orchestration. Okay, these slides are sort of in dark mode, except now they're rendered as light. So if any of the animations look a little wonky, that's why. Okay, yeah, so for example, you're going to now see a lot of gray on white text on background. So a lot of what I'm going to talk about today, I'm going to use the words I and we. And when I use we, I really mean these three folks. So just a huge shout out to one of our lead staff engineers, Chris Guidry, a staff platform engineer, Eddie Park, and then our founder, Jeremiah. Super instrumental, the three of them, in actually getting this stood up, and totally impossible without their work and advocacy for it. So also just kind of a heads up, everything in this talk is like basically not funny after 2017. So I shared a version of this talk with a friend of mine, basically to just QC every meme that I put in a talk ever. And he keeps sending me back the same thing, which is just like Office Space stopped being funny in 2017. And so if you were born after 97, you're going to have a hard time in this talk. If you're born before 97, you're also not going to enjoy it, but for a different reason. Okay, so to talk about real-time event-driven orchestration, I want to talk a little bit about, this is fundamentally a ClickHouse talk, but to contextualize what ClickHouse enabled, kind of a new category of functionality for us, I should tell you what Prefect is and what we do. So really the way I'm going to think about this talk is basically like how ClickHouse really just sort of enabled Galaxy Brain orchestration. So I'm going to talk to you about sort of what simpleton orchestration looks like, what mildly intelligent orchestration looks like, and then all the way back to basically what ClickHouse enables us to do. Oh boy, okay, so now you can see the real dark mode, light mode stuff come out. Let me, is there a, Ryan, sorry to bug you, is there a way of serving this just like straight from the browser? Or did it actually just show up like this?
So we copy and paste it. What is somewhere?
I don't. I'm so sorry. If we do the PDF thing, I don't know if that's the deal. Yeah, that might be a problem. Oh yeah, your email address, sure. Before every talk I ever gave in grad school, I would always empty out my entire email account, and then I would just have like one address, like email to myself with the, with the attachment essentially saying like, this is the greatest talk ever. I would fake emails from my parents saying like, good luck on this talk. And so I was always trying to see if I could get people to like read my email, and when they would laugh at the beginning of the talk is when I'd start, sort of mocking them for doing that. Yeah, that's fine.
Oh, but it's not showing the box.
Because we got to plug it back. Thank you, Ryan. I appreciate it. We're almost there. We just can drag. I think you can click and drag. Hey, cool. All right. Thanks, folks, for your patience. I think we might just have like an email backdrop. So you're going to see just how bad Ryan is at checking his email throughout this entire talk. And so I'm going to kind of have to scroll off screen here, which is fine. Okay. But now we're back in dark mode, so life is fine. Where was I? Yeah, so I'm going to talk to you a little bit about what Prefect actually is. So to tell you what Prefect is, I sort of have to tell you what workflow orchestration is. So if you're not an engineer, it's probably best to think about workflow orchestration as a micromanager for your code. There's really 4 things you have to tell a workflow orchestrator what to do. And then it forms kind of a contract that we enforce on your behalf. So the first thing that you have to do is you have to tell us essentially what code you actually want to execute. once you tell us what to run, now it's really a function of where you actually want to run it. And so, Prefect is really a platform where you can bring your own compute. So we don't sell compute. You basically bring whatever you want to run jobs on, and we'll submit it to your infrastructure on your behalf. Then it's really like how you actually want to run it. And so, for example, if you're submitting to Dask or you're submitting to Ray or to Spark, it's one thing to specify your infrastructure. It's another thing to specify, for each map task, what are specific job variables that you want to submit. There's also a bit of stuff here around like, when I talk about how you want to run things, a lot of this is kind of like the insurance angle of workflow orchestration, which is if something fails, what side effects do you want to take against it? If something fails for a 503 error, you probably want to do some sort of exponential backoff. If fails for a 499 error, it means that like LinkedIn is onto you and you're scraping, or like you're basically scraping regime here. And so really it's this function of what do you want to do when you hit a failure, and do you want to have any sort of custom behavior as a function of that? And then the last piece here is going to be around exactly when you want to run it. And so this is really kind of like bread and butter orchestration. A lot of people think about orchestration as scheduling as sort of like one and the same, but this is really kind of one component of actually building an orchestrator. You really have to decide what to run, where to run it, what to do when it fails, and when you actually want to have this thing submitted. And so Prefect is really an open source framework that makes it dead simple for you to actually write these contracts in pure Python. So Prefect is not a thing where you have to like author a DAG ahead of time. It doesn't actually feel like you have to go learn an entire framework to use. If you know how to use Python, you know how to use Prefect, and we make a really dead simple way of actually expressing these workflows in code. And so developer experience is probably one of the biggest things that we're obsessed over. This second most thing that I'm obsessed with is really trying to understand the family of triggers that you can actually kick off a workflow in response to. So if workflow orchestration is this contract between code, infrastructure, and triggers, I'm dead set and just kind of obsessed with expanding the family of things that you can use to kick off work. So 6 years ago, if you were doing batch ETL, you would do the like simplest thing possible, which is basically, oh, there's like a little bit of our DevX, so I'm getting this out of order. You do the like dead simplest thing possible, which is like, look, every single morning at 6 a.m., I want you to go sync these two tables. Like every third Thursday of the month, if it's a full moon, go ahead and do this. And so this is really like the most base form of how you can actually schedule work. And this is like what open source projects like Airflow were really built on, which is like at a specific cron string, can I go and kick off some work? And so as we sort of have obsessed over the years of kind of pushing the boundary of what's allowed to kick off a family of work, we've really expanded our category of what we can call a trigger. And so a couple of years ago, it definitely would have been just like, cool, I can kick off work at a certain time of day. But then what distinguishes Prefect fundamentally is that it's event driven. So not only can you push events into Prefect, but every action you take in Prefect generates its own event. Every event in our system is something that you can use to take a side effect against. You can trigger downstream work. And so one of the classic examples of this, not to be too theoretical here, is really like this use case of, I've got a customer or user that signs up for this platform. I want to go ahead and ETL their Salesforce data on their behalf. I want to go sync their contacts from Gmail. I'm trying to do ETL on behalf of a user, and it's an incredibly unacceptable user experience to basically say, cool, for any users that sign up between 5 and 6 p.m., let's just go sync all their information at 6 p.m. And so, whereas we really sort of got into companies on the ground floor of data engineering, as folks fell in love with our developer experience, we started seeing more and more teams from like the pure application side trying to say, cool, well, what I really need is I need to kick off this long running job, and I need to kick it off every time a user signs up. And so this is exactly what got us at Prefect a few years ago to start moving into event-driven orchestration. And of course, like, once you give somebody a little taste of event-driven orchestration, now suddenly a whole host of new demands show up. And so the sort of next step here in the hierarchy of needs of an engineer in doing orchestration is really like, if I can subscribe to and take a side effect against a single discrete event, how do I take a side effect against a family of them? So you can imagine that I've got a workflow that depends on 3 upstream dependencies. A, B, and C. Each one gives you an updated status of this is ready to be I'm now in a ready status. And so Prefect, you can subscribe to families of these triggers. And so now you can say like, cool, my upstream dependencies A, B, and C are now ready. Now I can actually go, I can join them, I can transform them, and so on. And so, but of course, we're really obsessed with expanding this family of what sort of work you can actually do. And so, we were happy 6 years ago when we could do it based on time. We were happy a few years ago when we could do this in an event way. Doing this against family of events was a harder engineering problem we took on last year. But of course, like the real kind of like white whale in all of this is how to do real-time side effects against aggregations of events, which is like a mouthful, but I'll tell you exactly what I mean here in a second. So the biggest thing for us here is folks often want to take side effects on what they consider to be like health of their system or health of their workflow. So taking a side effect against a single failure is like, yeah, sure, orchestration 101. But if I want to take a side effect against, I've seen this workflow or upstream dependency be unavailable on average within a certain time window, now I want to go and take a different effect. So I'll give you some classic examples here in a second. These are questions that we could, like, from an observability and an orchestration point of view, never really answer for our customers, which is like, look, how much does a workflow that we execute cost on average? If it starts exceeding about $100 a run, like I'm okay with something going above $100 a run, but if I start seeing this behavior on average, I want to actually start getting notified about this. If it starts exceeding a higher threshold on average, I want to start requiring manual approval of this workflow. I'm okay with like some inflate to my cost, but as an EM, or a platform engineer, I basically have to like herd a bunch of cats into like not ruining our internal compute. And so if it starts exceeding this on average, start to require manual approval. And if we start seeing that costs are increasing at a specific rate, we want to start declaring an incident. So these are things that are typically available in like more application contexts, but in the context of workflow orchestration has sort of eluded our industry. The other piece is like, if we try to understand how often this flow is succeeding. And again, it's the same story. If I start receiving an excess of errors, I want us to get alerted. If I start witnessing a spike in errors, I want to pause this schedule. It's so often the case that somebody will have a workflow that kicks off like every 25 seconds or something like this. And if you start witnessing that like an internal service is unavailable for the first, like, I don't know, 10 minutes of the hour, you've had 50 failures over a certain window, you really often know that you're gonna, all of your other invocations are essentially doomed to fail. So the ability to pause a schedule as a side effect of witnessing an aggregation of failures is something that our customers came to us saying like, look, if you're able to actually productionalize this, you can save us like tens of thousands of dollars of us spinning up expensive infrastructure to take on work that's doomed to fail ahead of time. And so the ability to monitor this in real time and be able to take side effects against it is a real boon to helping folks to save money in workflow orchestration. So this sort of dual problem I mean, you're gonna have to excuse me if you can't tell, I'm a recovering mathematician. So like when I mean like the dual problem, I mean like the literal dual of this problem, which is the sort of dual of orchestration feels like observability. And so vice versa, not only am I interested in observing how costly these things are on average, but how can I listen to these aggregation of events and take very specific kind of like orchestration actions against them? So some of the classic examples that we see all the time is, if we start seeing, I alluded to this earlier, is that if I start seeing an excess of say 499 errors on our big scraping job, that means that we need to rotate our residential proxy. If somebody's on to us, we know that, they've isolated our IP band. We know, they know from us that, we're trying to scrape their resources. We need this for our big evil hedge fund I heard earlier. And so how do I go ahead and rotate this? The other piece that's like been much more popular as of late is like, cool, there are a lot of indistinguishable model providers with GPT-4, I guess, on top, maybe Opus on top right now, which is if I start witnessing, say, the P90 latency of this LLM provider, if it starts exceeding a certain tolerable threshold or intolerable threshold for like, say, seconds to first token, now I actually want to like switch which model I'm consistently calling thereafter. And so the ability to listen to failures and take responses against them, not just in isolation, you'll have these APIs are incredibly inconsistent. You'll have really low latency on, 99 of 100 requests. You'll have something really slow, 1 out of 100. You don't want to go ahead and just blow up your entire pipeline. You want to sit and you want to monitor to see if on average, or say, some of those tail latencies start getting bad. You want to start taking action so that your future workflows don't fail or aren't late. And so scaling this at Prefect was really, really hard. So to give you a sense of the scale at which we're operating Prefect, maybe first I'll say is like Prefect is open source Apache 2 framework for doing this. You guys can all pip install Prefect and get started for free. Like ClickHouse, we have a cloud offering where we work with thousands of customers to orchestrate millions of jobs a month. Before this talk, I was absolutely convinced that we were the second biggest orchestrator, data orchestrator. And then about a week ago, found out that we orchestrate about twice as much as what we thought was the #1 competitor, Astronomer. So we orchestrate about twice as many tasks per month as what we thought were the biggest player in our space. So we're orchestrating about 200 million tasks a month, and each one of those tasks emits discrete events, whether or not it's logs being written when it's workflows entering different states. And this is in addition to events that people can publish directly to our platform. So generally, this turns out to be about 200 million events per day. And these events are semi-structured. They can be custom if they're submitted by our users, or they're somewhat predictable JSON arrays when they are submitted by our internal primitives, like something goes from scheduled to pending, which means it's in your infrastructure, or it goes from your infrastructure layer to actually executing in code. And a lot of the aggregations that we're trying to answer are kind of around events, which is a lot of the times people want to understand, look, if I start seeing that you're spending a lot of time in my infrastructure, but not actually executing code, that means that there might be something wrong with my build, there might be a degradation of service of my compute provider, and I want to actually take side effects against this. And so since these are like truly discrete events and we're trying to measure the difference between when these events are sent out, it's a time series problem we were really interested in solving. But often the demands here is that if you want to take side effects against this work, you really need to be able to do this in a real-time way, or else, when we were doing this in BigQuery, half the things that people want to take side effects against, you needed to be able to do it in much less than whatever the 10 seconds, 20 seconds that BigQuery was giving on some of this. And so, we went through this like stages of grief really, where we were really did not want to bring anything else into our stack, right? We had a lot of Postgres expertise on our team, and we just had this kind of immune response to the idea of bringing anything else in. We had Elastic in for our search index, and that was something that like really sort of flared up our immune response when we realized just how much time it took to tune this, how much it felt like we needed expertise to make this actually work. And so, but we hit a wall because this was a feature that like customers were knocking on our door to do. It was incredibly important for them to save tens of thousands of dollars a month in their own compute providers. And so finally, you have enough folks salivating, you realize that you've hit your limit with Postgres. You've like built all your right indices, you've re-architected all your tables, you've sharded by customer IDs, you've started like splitting events into like near term and long term so that you don't have to query as much when you're looking at like, say, the most recent sort of bundle of data. And then, we were really attracted to maybe we could use timescale DB to solve this, because we were still kind of like in this copium of like, look, maybe we can still keep this all in Postgres. Timescale is allegedly still Postgres. Maybe we can keep betting on this. We weren't able to get into timescale DB for a number of reasons. One, despite our fascination and expertise in tuning Postgres, hosting it is just not a thing that our team felt comfortable doing. And the second piece was like doing some, when it came to privacy stuff, like VPC peering wasn't really available at the time. And so we were basically back to like, okay, we're already trying to do this in BigQuery. BigQuery, our mantra internally is whatever question you ask it, it's 5 seconds and $5. And so it wasn't particularly effective for us to actually solve any of these problems. And The last thing that we had was Elastic, but after we brought Elastic in for search, we realized just like how difficult it was to tune it. It felt like we had to have somebody full-time basically managing these indices to respond to customer queries saying like, I'm searching by this string, why isn't this thing popping up? We just didn't have a lot of confidence in our ability to like tune Elastic to be able to solve this like incredibly important problem. And so that brings us to ClickHouse, because where are we at in this journey? We basically need to do real-time analytics, and we can't do this in a transactional way because we've done every transactional trick in the book and it's just not working. And so our founder is like just, you know, I would say that like the most excited to bring any technology into the company that he can. He's been a ClickHouse fan, I think, pretty much since your guys' first from the init, and has been looking at ClickHouse as really trying to solve this problem. But really, we kept kicking this can down the road for a while because we managed to kind of like, you build the right index, you shard it, you can finally start building some of this functionality. But really, it started getting to a point where our larger customers were just not able to rely on what we had built there. So we transitioned to, so we really started getting more and more curious about bringing in ClickHouse. So the first conversation we had about bringing in ClickHouse, we were all pretty excited about it. We read every benchmark. It basically just seemed too good to be true. And one of the weird things when you build like dev tools is you just kind of assume that everything on marketing is just not correct, and that when you actually go build it yourself, it's just going to all be garbage. And so out of that meeting of the four of us, we never really assigned who was going to like go home and build the local version and dump a bunch of data in it. So all of us did it. And then we all came back to our next sync meeting, realizing that like we had all independently verified that at least locally with like 50 million or so fake events, we were able to get performance that were below our threshold. And so that really motivated us. This would have put us in October or September of last year, where we realized that ClickHouse really was a viable solution for us. And so this kind of moves into how I'm going to start talking about exactly like how we evaluated ClickHouse and the dividends that it's paid in not only our feature set, but how paradoxically we are somehow paying a lot less for it than we were paying with our sort of like clown story of Postgres. So I'm going to be brief. One of the nice things about being the last talk is that I was going to go into a lot of the like, and here's how we tuned this very specific thing. And then Brooke basically just gave away all of the nice performance optimizations. So I'm not actually going to repeat a lot of that. I'll just say that like in our experience, a lot of stuff worked out of the gate, and then we didn't have to do any real performance optimizations until we started like onboarding real production traffic. And then even so, the support that we got from ClickHouse and the documentation was just so rich that we luckily were kind of, we weren't fundamentally solving a new architecture problem, I suppose. Like if you've been to a ClickHouse meetup before, or you've watched videos of it, you've seen like a very classic case of like, I need to dump structured logs in this and do real-time analytics. And so a lot of those tricks that work for observability platforms definitely work for us on the orchestration side. So the pieces that were like really nice for us is it was familiar and ergonomic. I'll talk about what I mean by that. The performance was great. I'll tell you about how we are dumping more data into it than we ever dumped into Postgres, and we're paying less. And I'll talk about why we chose to go onto ClickHouse Cloud and what that's meant for us from a position of maintainability. It was familiar and ergonomic. So as I said, it's an easy query language with really, really great documentation. I don't know what split of folks here are like engineers versus EMs, but if you're an EM in the room, like you never have a fear of a bus problem when you're actually bringing in ClickHouse. In our experience, we definitely had that with Elastic. We were like, cool, the one person who tuned Elastic, if they ever left, like we'll never know how to search for anything ever again. But bringing in ClickHouse really felt like, all right, it's close enough to Postgres syntax. A lot of folks know Postgres. A lot of the performance optimizations that we're doing are not like big brain. And so it really made us comfortable that like between the documentation, between our established expertise in Postgres, this is like not something that we're afraid. I mean, you know, if any of these people ever left, like I would, you know, obviously would be devastated, but it's not something that would compromise the integrity of the product that we're building, which is a huge fear when you bring in a new technology that really requires expertise. it didn't feel like we needed a ClickHouse person is probably the best way I can put this. And I was going to talk about, there was like few nuances, like we kind of just like YOLO in a bunch of indices when we work in Postgres, like a primary key might as well just be for free. This is not the case, obviously, in ClickHouse, just because like in our experience, like everything that you do needs to be like incredibly thoughtful, because if you start making too many changes to kind of like the base implementation of it, actually, no, this is a very good example of what Brooke brought up, right? Around like skip indices, right? So if you start making very small changes at the beginning, maybe you get some performance gains, but if you start like over optimizing, then you're actually kind of worse than not doing anything at all. And so there are a lot of pieces around here where from Postgres land, we were used to just like kind of YOLOing in a lot of this stuff. And so really the use of skip indices, projections, and materialized views really got us from like, to be able to serve a lot of these queries in much less than the query time that we needed. On performance, it's insane. So the compression and query speed is just, it's hard to articulate. I've got like a Datadog graph, but it's never going to capture the feeling of like the Slack huddle of when we were actually staring at it. And so, you know, you guys really have to close your eyes and imagine the feeling of seeing like the collapse of your query distribution. When you're like P10 is the same as your P75, there's just like a very, very good feeling about that. So before we moved to ClickHouse, 30 days of events in Postgres was 12 terabytes. And then when we emptied out everything back till 2022, it compressed down to 9 in ClickHouse. And so there was this crazy feeling of like, okay, the compression is just so brilliant that, and it kind of felt strange that they would kind of do us this favor because they charge based off of storage. And so the idea that they would essentially reduce our bill by, I said I was a mathematician, but I'm not an arithmetician. So the fact that they would, you know, decrease it by whatever the right fraction is just kind of felt insane to me. I kind of expected them to like not do any of that compression or charge us like some compression ClickHouse unit that we can't compute or something like this. But I was very, very surprised that like they make money from storage and yet we're doing us this huge favor that Postgres would never do for us, right? Or that, you know, Google GCP would never do for us. The other big things was, you know, I talked about like, what did life look like before we went to ClickHouse? I don't think I told you about all the stuff we did out of like coping, but I don't think I told you how bad it was. Just in our UI, we would try and display like how many events occurred for this workflow. So we weren't even just trying to grab lists. We were trying to do simple counts. And remind you, like we were trying to do counts, and then we were trying to bet like our next feature on the ability to do arbitrary aggregations. And our counts were so bad that we basically just accepted that 30% of our count queries were going to time out. Now, one of the nice things about being an orchestrator is we know how to retry things. And so even though, you know, 30% of our queries were timing out, we were basically just saying like, yep, the first one's going to time out and then the data is going to be warm, so we're going to be fine. And these are the things that you have to deal with when you're trying to use BigQuery through an application, right? And so for us, I think we had just kind of grown so accustomed that like, yeah, cool, like OLAP stuff is slow and you can't really serve it from like this is a nice thing for a dashboard with a nice countdown timer that says it's going to be ready in 5 minutes or whatever. And it did not feel like a thing you could build a serious application on. And so our timeout rates on counts, I mean, of course, dropped from like 30% to less than 1%. And our timeout rates for just like literally like get and list queries dropped from about 3% to less than 1%. So this is the famous graph, which is, so this is what query performance looked like. I used to have a dotted line that basically said when we would time things out, but you can just assume like anything that was a spike got timed out. And you'll see two things happening here. Like one, hopefully you can tell when we turned it on. And then hopefully you can tell when we turned it on and then we had an IoT company start using us. So when you have somebody running a workflow every like 100 milliseconds to check whether or not an air conditioner is on or not, that was a bit overwhelming for our like lowest ClickHouse cluster at the very beginning. This is before we made a lot of performance improvements. But you see like a complete flattening of the distribution when we actually turn it on something like 12:15. The other thing you're going to see though is you're going to see like now an asymptote where everything gets kind of our P10 basically paid a huge price, but obviously for engineering, you care about variability, right? You care about do I have some sort of expectation about how my system is going to perform? So I prefer no surprises to like really, really, really good low latency performance, and then now I have absolutely no idea what any of my customers are experiencing. Can anybody guess why there's now like an asymptote? Why like our P10s were so good and then now they're not good? What's up? No, maybe, but it's dumber than that. Say it again? It's not indices. This is never ask a database optimization question at 8:45 on a Tuesday. No, this is no, those are very good guesses. I don't mean to make too much fun. This is like a cross AZ egress, right? So one of the things that like that's the one dark side maybe for us in particular, we're on GCP East. ClickHouse doesn't support GCP East. They're in GCP Central, so we pay whatever egress like latency just between areas. And so this is something that's just like such a quick layup for us. Whenever it gets to the GCP East, we'll obviously see a lot of this crater. But so that was like the one hiccup for us. Okay, so on price, again, maybe this is not super important to like, hey, I want to use ClickHouse, but if you're somebody that's like, do I want to pay for my team to use ClickHouse? Let me tell you about how it saved us paradoxically a lot of money. So Postgres, specifically Cloud SQL and GCP, it's high storage and high compute because they got to keep everything warm. For BigQuery, it's like you just can't beat it on storage costs, but it's really high compute when running queries. Again, it's that like everything is 5 seconds, $5. But ClickHouse is like this ClickHouse Cloud is this very, very nice middle ground where it has moderate storage costs, it's about $40 a terabyte per month, and then moderate compute costs. And so what this meant for us, actually, I might be able to show like the live reaction into this, which is, yeah, here we go. This is a conversation between lead staff engineer and guest appearance by our CFO, where it's like, hey, look, we're spending $3K less a month. Now we're routing stuff away from BigQuery. We're saving $1,000 a month. And it's literally like, cool, you guys are ready to go from our CFO. So like, these are the types of conversations that happen when you move to ClickHouse, which is you have the CFO who's like really afraid that the engineers are running wild with like a new fancy technology. And why can't we just keep keeping stuff in Postgres? And then this is the kind of layups that you get to do internally. It's a really nice feeling to tell a CFO that cloud costs are going to go down. And the last piece about maintainability. So I would say that my favorite thing about ClickHouse, is I don't have to think about ClickHouse. We sort of have a mantra at Prefect, which is like, we hope you don't ever have to think about Prefect, because if you think about us, that means something went wrong. And I think it's you might not appreciate it as somebody who like sells reliability things to people, which is the more they think about you, the worse of a job that you're doing. And so conversely, ClickHouse is doing a great job for us because we never have to think about them. We used to have to watch Postgres like a hawk. Like there would just be like literally some poor on-call engineer every single week who would have to essentially like write indices for a query that a customer was complaining about. And it was so performant out of the gate, we rarely had to devote time to low-level optimizations. And so we've been in prod for about 2 months, about 10x our usage, and just sort of crickets. There is one thing I'll mention on maintainability. I was invited that like I'm not allowed to just like say all nice things about ClickHouse. I have to find some rough edges to tell folks about. I think the rough edges are just like, as you can imagine, when we're on Postgres, we get to just like use PG Bouncer. It's developed, really well developed by the community. For something like ClickHouse, we have to do a lot of like that. We have to do a lot of that connection pooling, connection management ourselves. And so when that's not really well tuned, we get a lot of like, hey, too many connections, errors. And that can be tough when you're building an orchestrator because like not everything is just serving a UI where somebody's, has an expectation that maybe something is stuttery and then they refresh. This is stuff where like, if we miss an event for whatever, that could mean that somebody's like incredibly expensive machine is running for like, say, 10 minutes longer than it's supposed to. And so the ability to manage those connections was something that we had to do internally. But at a like a user council meeting yesterday, this was enough of a discussion where I think that there's like some of us that are actually just going to like all work on an open source like ClickHouse PG bouncer equivalent. And so the conclusion here, sorry for dragging on a little bit, which is the conclusion is that it worked, right? So through all of that ClickHouse standing, right? Like what was the actual point of this all to begin with? And remember, it was customers are trying to respond to like aggregations of events that we take in real time. These are events that are emanated from their infrastructure, emanated from their workflows that they're custom submitting. And so now folks can not only just say like, hey, I witnessed a failure, pause this schedule. Now they can side effects of saying, I've witnessed enough over a threshold over a window of time. Now I want to take a side effect against it. And so thousands of jobs today are triggered over real-time aggregations of events. Totally impossible. I mean this, totally impossible without ClickHouse. And so our deepest thanks. And the result for our downstream customers are saving a ton of money on cloud infrastructure by avoiding work that's inevitably doomed to fail. And that's how we built Galaxy Brain orchestration on ClickHouse. A lot of duplicate slides. One thing I will say here, which is I mentioned that like there's dual problems to orchestration and observability. Everything that I've said about orchestration and what ClickHouse enabled for us on that side also paid dividends on our observability side. So now folks, when they're looking at like their ECS work pools, now have a good understanding of like, what's the average duration of a job run on this infrastructure? How late is it on average? What's the success rate of this? This is all stuff that's served real time out of ClickHouse for really, really high or for low latency workloads. And then the last piece is just kind of about chilling Prefect. So if you write Python, you want to orchestrate jobs, Prefect is basically like Airflow, but you don't want to throw yourself out a window while you use it. We've got a large, vibrant community, about 30,000 folks. Airflow is fine. I don't have anything against Airflow. But come join us in Slack. Come use us. It's just like the most dead simple way to getting started with orchestration in Python. Really, really excited by the adoption and enthusiasm from our community and from folks adopting Prefect everywhere from like startups to enterprise. And so really, really been just, I think, humbled by the excitement and the adoption. So that's it, really. I'll say that if you're interested in following more about Prefect, we're Prefect.io on Twitter, and we're hiring. So check out our jobs page. We're hiring for a platform engineer and hiring for a full stack engineer. So thanks for listening.
Questions?
Oh, no 850 workflow orchestration question? Oh, yeah, sure, yeah.
Hi, yes, yeah. Thank you for the talk. So
Yeah.
I have a question. So
Yeah.
how do you load data into your ClickHouse? Are you using like, asynchronous in source, or are you doing it in batching?
Just very typical change data capture. So like
Through Kafka or directly?
Debezium Kafka, just
okay.
like same as I mean, that's the nice thing about going last is like Ramp gets to talk about like, cool, this is how we sync it. And then Brooke from Bandit got to talk about all the performance optimization. So
I'm just staring at the infinity window. Oh, it's
yeah, sure.
Sorry. Other questions? All right. Well, I'll spoke too soon. All right. There's one.
I would like to ask a question about the you mentioned you have some unvalidated events which you would like to calculate and do some aggregation. Usually this might be related with some data queue, I'm guessing. So what is the mechanism you dealing with that kind of unvalid schemas? I mean, you might have to do some schema registry or do some modifications for those data.
Yeah, so provided I understood the question correct, so you might want to keep the microphone up, which is the way that we deal with custom events is like there's only a handful of ways you can submit events to our system, and they have to be submitted through like a pretty rigorous schema through like a webhook essentially. And so like we don't really deal with like you know, somebody sends some arbitrary JSON that like we don't know how anything to do with it, we do ask folks to like submit events according to our schema. So like we're not just like totally effed when we have to process their events.
Okay, so that means all the registered schema you have stored them in the SQL database or something, ClickHouse.
Well, so wait, so like how do we do? Can you? I think what the question I was answering was more about like how do we ingest events from our users like into our system, or the question is like, given that we have custom events, how do we actually like performantly query them? Sorry.
Yeah, the previous one. The customer, you have to customize the they call it the events.
Yeah, so for this, like it's when you set up, say, an event webhook in our system, like there's a very specific schema that you submit it through, and off that schema, like we only have like a handful of ways that you can actually customize it. So if you want to like submit a very specific like float, basically, and now we can go and calculate metrics based off of that, but we're not on the hook for you basically saying like, I've got my own custom structure or struct for an event, go figure out how to deal with it. And so I think for us, like we really are strict on how you submit data into our system. And then for that strictness up front is how we get the sort of ability to aggregate it on the back end without having to think through all the like the weird corner cases.
Okay, I got it. Thank you.
Any other questions? No. Okay, cool.
Thanks,
Well,
everybody.
thanks, folks. This is a lot of fun.